This is Module 3 on zoning and permitting. So before a client gets too excited about installing a wind energy system, it's probably a good idea to find out if it's even legal in his or her jurisdiction. There's going to be things to consider, such as restrictions, ordinances. There might be setbacks that have to be looked at. This module, we're going to be looking at the technical aspects of installing a wind turbine that we really can't ignore. Again, this same material was developed in partnership with the MREA, Focus on Energy, Mick Sagrillo, Sam Simonetta, and Jenny Heinzen, just like the last ones. And we see the same contributors, authors, reviewers here as we had in previous modules. So the things that we're covering in here, we'll talk about zoning and permitting. We'll talk about FAA requirements, typical concerns, and some of the toolboxes that are available for us to use. So siting. It might turn out that we've got a really good wind resource, and the electrical service might be fine, but it may also be that zoning and permitting can stop a project. I know from personal experience, when I began to put mine in here in the city of Watertown, or I'm sorry, in the town of Shields, which is in Dodge County, there were very little. There was a wind energy system ordinance that was kind of onerous, and it limited the size of my turbine to be 100 feet. And it had to stay on my property if it were to tip over. That was a setback. And 2 years later, they made it even tougher. Now I can't have a turbine taller than 75 feet. Well, of course, mine is grandfathered in, but what's that going to do for a person who wants to put a machine in? As we've learned already, putting a turbine on a short tower just doesn't make any sense. So it makes it sound like that perhaps some of the politicians and neighbors just don't want turbines in the area, because if they understand that putting a turbine on a short tower doesn't make sense and then restrict turbines to only be on short towers, towers won't go up. So that's really a bad situation. Another issue shown here is aesthetics and proximity to neighbors. My closest neighbor is a quarter-mile away, and when I spoke with them, neither one of them had a problem with the turbine going up. Even the neighbor to the north that flies a small plane in and out of his property, goes right over the top of my barn. His comment was, "If I can't miss your wind turbine, I shouldn't be flying an airplane." I appreciated that attitude. But as far as FAA restrictions go, the federal regulations, part 77.9 is on the FAA. And you got to contact them if your site is within 3.8 miles of a public or military airport. And there are restrictions as to how close you can be. You'll notice that if the runway is longer than 3,200 feet, then we're going to have a 100-to-1 surface ratio. I'm going to show you something on that on the next slide. If the site is within almost 2 miles, then we're going to have, and the runway is shorter, then we're going to have other restrictions. The surface ratio changes, and so it needs to be closer. So if I'm within 5,000 feet of a public use airport, then the tower height is going to be extremely limited. Now, if I have a tower height if I'm that close to one of these airports, then my tower height cannot exceed, if my tower height exceeds 200 feet, it doesn't matter how close I am to an airport. That's not going to be an issue for small wind. We will not be installing small wind turbines on towers that are that tall. The cost involved in that wouldn't make it worthwhile. So Form 7460 is something that I'll have you see if you can find as part of a homework assignment, and it shouldn't be that tough to find, but still it'll be a good experience. So the surface ratios that we were talking about on the previous page, 100-to-1 means that for every 100 feet from a runway, I can go 1 foot tall. So if I'm 1,000 feet from a runway, I'm stuck with a 10-foot tall tower, right? Now, if I'm 3 miles away from the runway, right? That would be 20,000 feet. Then I can have a 200-foot tall tower, right? So again, you see, now this would be for runways that are longer than 3,200 feet long, right? So, so that's about what, 5/8 of a mile. Now, if it's a shorter runway, if it's less than 3,200 feet, then we have to drop down to a 50-to-1 surface ratio. So for every 50 feet you are away, I can go 1 foot high. So you can see that this actually works out pretty well here. I can be just 2 miles away and have a 200-foot tall tower. So so we're in good shape here. Let's see. It's anytime I'm 5,000 feet from a heliport, right? That might be near a hospital. Then we're going to have a 25-to-1 surface ratio. And you'll notice that there's a source here on the bottom, nwcommunityenergy.org, wind/permitting-1 and other approvals. Okay, so we can find this. And now anytime I have a tower that's 200 feet tall or taller, then I'm going to have some sort of lighting on it. It's actually FAA approved lighting, and it can add considerable cost to a system. So here's an example of slope ratios, right? And so you'll notice that the planes have this x distance factor here, right? So here's the slope ratio of 130-to-1 if the runway is more than 3,200 feet. If there isn't a runway with more than 3,200 feet, then I can lower the slope ratio to 80-to-1. So again, we have to be sure that that's one of the first things you want to check when you're looking at a customer or a client who's thinking about putting a turbine up, is just how close are they to a public or military airbase. So now we're going to start talking about the report template, right? You've probably downloaded this already. That would be a good thing. And this is section 2, where we're going to talk about the general description of the site. Notice we have to put the latitude and the longitude in here. Many of you have seen how to do that with your smartphones. We can get this acreage size of the property and the soil type. Now the soil type is in southern Wisconsin is pretty common. To be a loamy type soil, but the place you can find out for sure in Wisconsin is to get in touch with the local UW extension. Most counties have one of those that work with the farmers. Name of the nearest airport, and then the distance of the airport, and direction. Is it southeast or north or what? And so then again, notice it tells us that we want to describe the client site and any other factors that are going to influence the siting of the turbine on the property, and expand on the FAA regulations as available or appropriate. So this is, again, the template shows us, and I'm going to scroll over to the template for a moment here. So if I get over the template, right, this is again, how it looks. And so notice we're going to put the client's name here, and then underneath that we'll put a photograph of it. We'll put in our contact information, and if we have an MREA assessor certificate, it's not required to have one here. You can become an assessor without that certificate, but it may just add some credibility to your job title. So notice the client profile is section 1. And we talked a little bit about that in Module 2. So now here in Module 3, we're going to be looking at the location of it. So we'll have to have a site layout with a close-up aerial picture photograph, with a distant photograph, a close-up topographic map, and then also a distant topographic map. And it would also be a good idea to have some panoramic site photos. And that way we can see from 360 degrees direction from the proposed spot of the turbines. It's a good idea. So back to our show here, right? So Now, as far as the permits go, I've talked about this a little bit. When I put my turbine in here, I was required to get a building permit. I was required to get an electrical permit with inspections. The soil survey was not required. Actually, the electrical inspection wasn't required either. It was just part of the local building permit that was needed here. Depending upon the size of the machine, for example, the wind turbine at the Fort Atkinson Madison College campus, the large turbine, the 100 kilowatt machine, that had a significant amount of cement and engineering involved, and it did require a PE stamp on the project. And that was part of what the city wanted to do. Now, again, some cities and counties are going to have height limitations, which can actually be, really short. That it's the building or the structure can't be any taller than 35 feet, so that we can pump the water high enough to fight a fire. Most of those have been overridden, and so the 35-foot rule doesn't exist so much anymore. But like I mentioned before, in the Dodge County, they went from 100 feet to 75 feet. And in the city of Watertown itself, they didn't have a height limitation, but they had a setback limitation I'm going to mention to you here in a moment. Other things that could be required, for example, is if a person wanted to try to have a turbine that was on a tower that was taller, or if, for example, when I put mine in, if I wanted to put up a tower that was over 100 feet, I could have asked for a conditional use permit, or if I would have wanted to install it near a property line that my neighbor, even if my neighbor was okay with it, that if the turbine were to fall over and it would cross that property line, even if it only lands in a field, then I would have needed a conditional use permit. And one of the issues with that is the cost of the permit goes up significantly. So more money and more time, and sometimes it seems like what the NIMBYs are trying to do is just not have turbines go up. So if the ordinance exists, we may need to get a variance, and again, a variance costs more money. And plus, there are also different zones. Is it a residential, agricultural, commercial, industrial, or is it a natural area? And again, you're going to have to look this up in some of your scavenger hunt assignment that we had a couple weeks ago. You may have found some of this information already. Now, in the template itself, in section 6-1, we're going to go back to that, right? So in section 6-1, then we're going to talk about, notice here, in permitting and zoning. So the local ordinances, notice, so this is the table of contents that you will have in your report, and you will put the page number where these different things come in, right? So you're going to put all this information in here. So we'll go back and look at this. So again, this is the boilerplate information that the client is going to need to read this. This will be the information telling them why you've included this. It's highly recommended that the client research any and all local zoning and permitting requirements before making plans to install the turbine, and certainly before writing a check and getting it. Now, as far as setback issues here, I mentioned what I was dealing with here in the town of Shields, that I had to make sure that if my tower would have tipped over, it had to tip over on my own property, and it couldn't tip over on an electrical line or a phone or a cable. And so when I put mine in, that wasn't an issue. Now in the city of Watertown, they wanted their setback height was the total height of the turbine, right? The total height of the turbine, plus if one of these blades, if the rotor was turned and one blade was pointed all the way to the top, that is the total height. And what the city of Watertown requires is it must be located so that if it tips over, it can't tip over. It has to be at least 3 times greater than the tower height plus the blade length. That's right. I needed to be 300 feet away from any property line. And it was when we had it installed, when we had the Berge XL installed in Watertown, we were pretty darn close to one area, but we made it work. It's a silly rule. It's not like the tower would ever tip over and then tip over again and then tip over again. It would go down and stay. So silly rule, but we got around it. As far as the setbacks go, again, we want to look this up. You want to find out, what these include. Other things that might be pushbacks from people who don't want turbines in. People will complain about, the sound this thing makes. It doesn't look very good. It's going to affect my property value. Now, some of this stuff is valid, and we're going to talk about them individually here. We'll talk about shadows, birds and bats, communications interference. There's a thing that's known as abandonment. What happens when the thing breaks? And are we going to keep fixing it, or is it just going to stay there and look ugly? There's a stray voltage, and then also we've got severe weather issues, and there's some misconceptions that the public has. And again, this is our opportunity to educate in many cases. So as far as the sound goes, you'll notice I didn't use the N word, noise, sound. Everything makes sound. I'm sitting here right now in my house, and the wind is howling. According to my phone, the wind is blowing at a rate of, says it's only 8 miles an hour. I don't believe that. I think the wind is blowing considerably higher because I can hear it through my closed windows. I can also hear a train that happens to be about 2 miles away. So one of the things about sound is it's not measured on a linear scale. It's measured on what's called a logarithmic scale, and it's measured in decibels, which are abbreviated by dB. And so because it's not a linear scale, then 20 decibels is not twice as loud as 10 decibels. It's really hard to detect changes that are as small as 5 decibels. And we learned about the Small Wind Certification Council, and we saw that they listed and published those sounds. And if you remember, they're 200 feet from where the rotor is, right? Setbacks are typically used in order to determine what the sound limits are going to be. It would be great if they were legitimate and they were fair. But here's the thing. Sound is subjective, and on this next page we're going to see an example of that. So leaves falling, you can actually hear leaves falling, and they're about 10 decibels. Whispering is 20 decibels. The sound, I don't know, get this, the sound of a typical bedroom is 30 decibels. That must be just ambient noise in the room. A turbine itself, remember from the Small Wind Council, I think we saw one that was 55 decibels, right? So if there's 55 decibels, it fits in there. Just general noise about the home, people having dinner, cooking dishes and so forth, or working in the office. We're going to see the scale going up. Inside of a car, I guess that would depend upon the car. How loud stereo music is, what about industrial noise? So this is a good chart. And so again, here's the Small Wind Certification Council indicating that this particular turbine has a sound rating level of 42.9 dBA with a wind speed of 5 meters per second, which is about a little over 11 miles an hour, using the Raleigh wind speed distribution, and at sea level with 100% availability, and the observer somewhere around 200 feet away from the center of the rotor. All right, so I've encouraged you to do this before, and I'll do it again. I suggest that you all go visit a wind turbine and hang around for a while and listen to some of the things that you can hear. Of these things, and again, depending upon the type of turbine will determine what you will hear. If the turbine, for example, has a gearbox, you might hear it whine, rather. The generator can actually hum. Now, that's compared to, and so this is a case where maybe you come up to the turbine and the wind is blowing lightly. Maybe it's only blowing 7 miles an hour. And the turbine isn't actually generating any electricity yet, right? Remember we talked about cut-in speed? So if we haven't reached the cut-in speed where the generator is actually creating electricity, it will be turning but and then there'll be some vibration and some sound for that. But then as the wind picks up, hopefully you've had a chance to experience this, you'll see that the wind, once the wind picks up and the generator starts to hum, there's a whole different vibration and a whole different sound that's created by the machine. And it's very noticeable to hear this happen. Again, the blades themselves are going to determine how much sound is created by it, whether it's an upwind machine or a downwind machine. Also, the length of the blades. And the length of the blades is going to determine the tip speed ratio. Remember that the smaller machines have a much higher tip speed ratio and they really spin much faster, and so they create a much higher pitch sound as compared to the large machines that make more of a whoop whoop sound. Other things that we might hear on small wind machines could be furling springs. That's the tail that turns, that keeps the rotor out of the directly into the wind. Or maybe there's tail springs, or the case of the Proven Kingspan machines, maybe it's the coning springs. Generally, if they're working that hard, there's so much other wind noise that you won't hear that. This photo didn't turn out very well here, and this is the aesthetics. People are going to say, well, that doesn't look very good. I don't like how it looks. Well, that's not a very good reason in most rational person's mind. Like it says right here, beauty's in the eye of the beholder. Compare this to, for example, the smoke billowing out of a coal-powered plant, or even a natural gas-powered plant. I think this was far more attractive. Shadows are for real. I would encourage you to go to the Fort campus, the Fort Madison College campus, towards the afternoon or in the morning when we see the sun rising or setting. That's when we have most of the issues with shadows, because the sun is coming in at a lower angle, and the lower the angle, the longer the shadow. So that it would be easier for a home to fall into that shadow zone later in the day or earlier in the morning. But we got to remember that the size of those shadows and the amount of those shadows is going to change as the year changes. In the summertime, when the sun is much higher in the sky, we will see much shorter shadows. And by this I mean, for example, when you see the turbine in Fort Atkinson, there's a home in particular that falls just to the northeast of the turbine. It's on the lot right next door. And when the sun's going down in the afternoon, it's very obvious that there is an issue where the sun is going to cause shadows to crawl over the windows on that home. Now, how long will it last? It only lasts for a few minutes, and if it's a cloudy day, of course there aren't any. And so things that we can do to abate this, or to make it less of a problem, is trees could be planted in front of the windows so that this shading shadows wouldn't be as much of a problem. And then also the companies have been known to have window treatments installed into a neighbor's property. So these are some things that you may want to consider. And it's worth talking to with your clients. We need to mention to them and perhaps show them an example of how the shading, shadows and flickering is another term that's used. Flickering. Shadows is when the rotor is blocking the sun. Flicker would be when the sun is reflecting off the blades. And again, on small wind machines, the blades aren't that long, so there won't be as much of a flicker issue. Birds and bats. This is always one of the most often brought up pushback items to putting a turbine in. Well, what about all the birds that are going to be killed? And studies have been done, and you can research those. And most of these studies will only be done at the large wind farms. I recently drove through the Horicon area, and I saw flocks of geese flying all around all these turbines up there. I literally watched them dodging the blades. they'll learn to get around them. Um, but what was really interesting in the study that's shown here, the Woodland Dune study, is that the building itself killed more birds. Birds would literally fly into a window, boom, bounce off the window, dead. Cars kill more birds. So does that mean we don't want to be concerned and we don't want to try and reduce the amount of birds and bats that are killed by turbines? Of course not. But the wind industry has been pushing quite hard and long to try and mitigate the effects um, of these turbines. This again is a bad shot. Hopefully you can see that this is Fluffy the kitty here with a bird in its mouth. And my friend Mick Zagrillo likes to joke, save the birds, kill your cat. If you're really concerned with birds, then we should reduce the number of cats that we have outside, because cats are the leading cause of death in birds. Windows are the number one cause of uh, birds by human-caused items. So notice how small. This is less than 2%, less than 1%, okay, of the deaths of all birds. Pretty small. Uh, uh, just here 2 weeks ago, I was driving to work, and lo and behold, a bird was swooping in front of me in my car, and boom, my car hit the bird. There wasn't anything I could do about it. So there was another bird that was killed, and my turbine hasn't killed any yet. Eventually, the turbine is going to need to either be repaired or replaced. It's going to stop working. It will eventually break. They have a lifespan of maybe 20 years, and it may need to be repaired a few times in between there. What happens when it becomes not economically feasible to replace it? Well, some counties will actually have a requirement, or some jurisdictions will have a requirement that you have money in the bank that will remove the turbine if it sits idle and broken for a certain period of time. I don't think that's going to be that much of a problem with the smaller types of towers and turbines that we're going to have. I certainly haven't seen or heard of any uproars of windmills, old farm windmills sitting in the field. Quite often the tail is furled over. It's not turning. It's been locked and it doesn't work. The county isn't asking for those to be removed, but those aren't nearly as tall as what we'll have on our wind towers. So a couple of things that a couple of our experts here, Hugh Pigott, our British friend, our Scottish friend, he says, when bits start falling off, what are we going to do about it? And Mick likes to refer to it as turbine leprosy. So you may have to have a plan. You may have to have a plan, and maybe even a chunk of money in the bank. That just could be one of the things that you have to do in order to put a turbine up in your area, and so you need to research that. Stray voltage is definitely an issue on the farms, right? And it's really, I don't even like the term, because stray voltage isn't the issue. It's the real issue is unwanted current, unintended current. Normally, this is caused by improper grounding, either on the farm property itself or the utility. The utility is oftentimes the problem with the grounding issue. So what we have is a voltage that's going to be between the grounded conductor and other equipment grounding conductors. What does that mean? Well, that means, if we remember looking at our electrical, if we remember our electrical training, we know that a typical 3-wire prong in a home, you've got a hot wire, which is generally going to be black. You have the white wire, which is called your neutral, or your grounded conductors, sometimes called common. And then we also have the equipment grounding conductors, and those would be the green wires or the bare wires. And so there should not be any voltage between the neutral or common or white wire and the grounding conductors. There should be none there. And so this is something that might need to be addressed and should be addressed, because it's a safety issue with or without a wind turbine. So towers and turbines and the electrical equipment must be properly grounded in accordance with the NEC, so we cannot ignore that. Now, there are other types of electrical issues that have been called to question. which is not the same as stray issue. And it's listed here as electrical pollution or EMF or dirty electricity. Um, and it's kind of outside the scope of what we're doing here, but stray voltage is a generally an electrical grounding issue that we have to look at. Okay, and lastly, we want to talk about severe weather. Um, Putting lightning protection on your machine is always a good idea, because this will most likely be the tallest structure on a property, and it will most likely be the first thing that is seen by the lightning strikes. And so we want to make sure we put the lightning protection on there. There's a couple flavors that are available. Delta has made one for years and years that is it's really difficult to find out if it's working or not. Midnight Solar has one with lighting built into it, with indicators that are worthwhile to put in. You can get them both on the DC side and the AC side, and there'll be more with that. Just it's a little outside of the scope here. Your installer will know more about that. Strong winds and debris. I've seen strong winds, the sustained winds that may cause debris to fly. And when that debris is moving through the air, if your turbine is still spinning and a chunk of wood goes by, well, that blade is going to be affected. And I saw one of the Jacobs machines up at the MREA in Custer when we had some sustained 80-mile-an-hour winds. The tips of them were broken off. So we ended up having to shorten those blades and modify them because two of the three blades were damaged. Obviously, a tornado coming through will do a number on any structure, and a turbine is no different. So, they can happen. Other stuff that we might want to list when we're thinking about zoning and permitting. Attractive nuisance. This is an example of, if a kid sees it, they're going to want to climb on it. Recently, I heard about a local construction site up in the Verona area that it was found that kids were sneaking in, climbing to the top of the crane and running along the top of the crane, 150 feet in the air, and taking selfies of themselves and posting them on the internet. And so the company that owned the property had to get some additional security to make sure that nobody was trespassing on the property. Imagine the liability that would happen if one of those youngsters fell off the crane that they were climbing up. So we can have the same issue with a wind turbine tower. So what might we have to do? We might have to put a fence up. We may have to put up signs that say high voltage. Another issue we'll do quite often is we'll remove foot pegs or lower ladder sections so that people can't. It'll make it more difficult for a person to climb. And somebody who really wants to climb these things, they're going to climb it. Nothing says climb me more than a fence, right? So if I just put a fence around an area, that's not going to keep somebody out. It might slow them down a little bit. Other issues, fires. So if I've got a fire 100 feet in the air, how am I going to put it out? Might need to consider that. Ice can be an issue. Ice can be an issue if the turbine is sitting still and the wind isn't blowing and there's a buildup of ice on it, and then when the wind begins to blow and the turbine starts to turn, yes, there is going to be some shedding, and so you'll need to consider that and perhaps put some signage up. And be careful about what you put under the turbine and where it's located. Infrasound is the sound that the sound that can be transmitted to buildings in the area, and this is this can be some people have made more of it than can be proven. So again, this is just a term that you may see, and this is just one of the pushbacks. Communications interference is also very uncommon and unlikely to happen in most small wind turbine installations. If there is an issue there, most of the time it would be caused by some sort of electrical grounding issue as well. And then the very term, the wind turbine syndrome. Some people claim to have medical issues caused by being just in the mere proximity of being in a wind turbine. And so here's a source where you can go and do some more looking up on that. So Mick is really good in discussing these things. So when we're writing our reports, we want to refer to it with these correct terms, right? We don't want to call it noise. Let's refer to it as the sound that something makes. Rather than refer to a strobe effect or a shadow flicker, let's just refer to it as shadows. We get shadows from everything. People who have to drive east in the morning to go to work know what it's like to stare into the sun, and yet they don't move just so that they don't have to drive into the sun. They deal with it. Again, ice shed versus ice throw. Incentives for installations rather than subsidies. Subsidy is a bad word, it connotates bad ideas. So by using these words that are on the right side, it's a lot easier for people to have arguments towards opposition to putting in a turbine. So again, the template itself, we looked at that. There's a spot for frequently asked questions, and we might want to include some of these. And again, if we go to the renewwisconsin.org website in the Wind Toolbox tab, we'll be able to find some Q&A things that will help us, and we might even want to include them because perhaps the customer you talk to brought some of these very things up when they asked you to come and do a site assessment. So here are some of the places that were used as sources for information that can give you for further research if you'd like to do this. And you can pause this video and see them yourselves. And I think there's a couple more on this next page. And so there we go. That ends Module 3 on zoning and permitting. And I hope you found this interesting.